Welcome, dear students. Today our topic of deliberation is Contribution of Linnaeus to Biology. The objectives of today's deliberation are to briefly describe Biography of Linnaeus, to discuss the contribution of Linnaeus to taxonomy, that is, hierarchical classification system and binomial system of nomenclature, to delineate Linnaeus's thought about fixity of species, to highlight the scientific work of Linnaeus. So, first and foremost, let us have a general introduction about Carolus Linnaeus. Carolus Linnaeus was a Swedish botanist best known for his work on classifying and naming different biological organisms. He published Systema Natura in 1735, in which he outlined the way of classifying plants. The classification system was primarily based on his expertise on plant sexuality. Linnaeus simplified and standardized nomenclature into binomial system, two-name system of genus and species to make scientific names shorter, more accurate, and universally applicable. Because Linnaeus was first to achieve a consistent and efficient system of nomenclature, botanists agreed in 1905 to accept his Species Plantarum, 1753, and zoologists agreed to accept the 10th edition of his Systema Natura, 1758, as an official starting point for scientific names of plants and animals. His Systema Natura went through many revisions over time and came to include all living things. Other noteworthy contributions include the scientific works like Genus Plantarum, Philosophia Botanica, Flora Japonica. Although the classification systems used today are primarily based on phylogenetic systematics and genomics, the preliminary work done by Linnaeus still holds significance. Now let us go through our first objective, viz. Biography of Linnaeus. Carolus Linnaeus, or Carl von Linné, was a renowned botanist, physician, zoologist, and one of the most influential scientists in history. He is known as the father of modern botany. Linnaeus was born on May 23, 1707 at Stenborn, southern Sweden. Linnaeus entered the University of Lund in 1727 to study medicine. A year later, he transferred to University of Uppsala. Most of the Linnaeus's time at Uppsala was spent collecting and studying plants. At that time, training in botany was a part of medical curriculum, for every doctor had to prepare and prescribe drugs derived from medicinal plants. Linnaeus went to the Netherlands in 1735, promptly finished his medical degree at University of Harderwijk, and then enrolled in the University of Leiden for further studies. That same year, he published the first edition of his classification of living things, the Systema Natura. Returning to Sweden in 1738, he practiced medicine and lectured in Stockholm before being awarded professorship at Uppsala in 1741. At Uppsala, he restored university's botanical garden. Linnaeus continued to revise his Systema Natura, which grew from a slim pamphlet to a multi-volume work. As his concepts were modified and as more and more plants and animal specimens were sent to him from every corner of the globe. In 1758, he brought the manor estate of Hamri outside Uppsala, where he built a small museum for his extensive personal collections. In 1761, he was granted nobility and became Carl von Linné. His later years were marked by increasing depression and pessimism. Lingering on for several years after suffering what was probably a series of mild strokes, in 1774 he died in 1778. Now, let's briefly discuss about his scientific outlook. Linnaeus loved nature deeply and always retained a sense of wonder at the world of living things. As he wrote in the preface of late edition of Systema Natura, the earth's creation is a glory of God, as seen from the works of nature by man alone. The study of nature would reveal the divine order of God's creation, and it was naturalist's task to construct a natural classification that would reveal this order in the universe. Much of what we do today has its foundation on what Linnaeus organized more than 280 years ago. Dear students, with this, we have reached our second objective, that is, contribution of Linnaeus to taxonomy. Carolus Linnaeus is often known as father of taxonomy. His system of naming, ranking, and classifying organisms is still in wide use today. His ideas on classification have influenced generations of biologists. Two most important contributions of Linnaeus to taxonomy were hierarchical classification system, binomial system of nomenclature. Let's first discuss about hierarchical classification system. Linnaeus presented a hierarchical classification or taxonomy of three kingdoms of nature: stones, plants, and animals in Systema Natura, the system of nature. In this system, 5 hierarchical categories were used: variety, species, genus, order, and class. Classification of plants. The classification 1735-1753 of Swedish botanist Carl Linnaeus represents the most complete artificial system ever developed for all plants. The system of classification proposed by Linnaeus was based solely on presence, configuration, and number of sexual parts of a plant. A plant's class was determined by its stamens, male organs, and its order by its pistils, female organs, referred to as Systema Sexuale. Such a classification based on stamens and carpels resulted in the artificial grouping of unrelated taxa and separation of relatives. This sexual system, as Linnaeus called it, became extremely popular through certainly not only because of its practicality, but also because of its erotic connotations and allusions to contemporary gender relations. The system of Linnaeus was very simple in its application, recognized 24 classes. The Linnaean classes for plants in sexual system were: Class 1, Monoandria, flowers with 1 stamen; Class 2, Diandria, flowers with 2 stamens; Class 3, Triandria, flowers with 3 stamens; Class 4, Tetraandria, flowers with 4 stamens; Class 5, Pentraandria, flowers with 5 stamens; Class 6, Hexandria, flowers with 6 stamens; Class 7, Heptandria, flowers with 7 stamens; Class 8, Octandria, flowers with 8 stamens; Class 9, Enandria, flowers with 9 stamens; Class 10, Decandria, flowers with 10 stamens; Class 11, Dosandria, flowers with 12 stamens; Class 12, Icosandria, flowers with 20 stamens, perigynous; Class 13, Polyandria, flowers with many stamens inserted on the receptacle; Class 14, Didymnia, flowers with 4 stamens, 2 long and 2 short; Class 15, Tetradynamia, flowers with 6 stamens, 4 long and 2 short; Class 16, Monoadelphia, flowers with the anthers separate but filaments united, at least at the base; Class 17, Diadelphia, flowers with the stamens united in 2 separate groups; Class 18, Polydelphia, flowers with stamens united in several separate groups; Class 19, Syngensia, flowers with 5 stamens, the anthers united at their edges; Class 20, Gynandria, flowers with the stamens united to the pistils; Class 21, Monoecia, monoecious plants; Class 22, Dioecia, dioecious plants; Class 23, Polygamia, polygamodioecious plants; Class 24, Cryptogamia, the flowerless plants, including ferns, fungi, algae, and bryophytes. As a result of its utility, as well as the interest generated by its sexual anecdotes. For example, Diandria was described as 2 husbands in the same marriage. The system became very popular and was accepted virtually worldwide. However, Linnaeus's plant taxonomy resulted in many groupings that seemed unnatural. For instance, Linnaeus's class Monoaceae, order Monoadelphia, included plants with separate male and female flowers on same plant, Monoaceae, and with multiple male organs jointed onto one common base, Monoadelphia. This order included conifers such as pines, firs, and cypresses, but also included a few true flowering plants such as castor bean. Plants without obvious sex organs were classified in the class Cryptogamia, or plants with a hidden marriage, which lumped together the algae, lichens, fungi, mosses, and other bryophytes and ferns. Linnaeus freely admitted that this produced an artificial classification, not a natural one, which would take into account all the similarities and differences between organisms. Linnaeus did aim at natural classification, and in the 6th edition of Genera Plantarum, 1764, he appended a list of 58 natural orders. It was, however, left to others to carry forward. Dear students, let's now talk about contribution of Linnaeus to binomial system of nomenclature. Despite numerous new ideas and systems of classification produced from 16th to middle of the 18th century, names of the plants continued to be polynomial, that is, many descriptors, words following a generic name. For example, tomato was named as Solanum colli, Intimi herbaceae, Follis pinnatus, Incinus, meaning solanum with a smooth herbaceous stem and incised pinnate leaves. Many biologists gave the species they described long, unwieldy Latin names which could be altered at will. A scientist comparing two descriptions of species might not be able to tell which organisms were being referred to. To avoid this cumbersome way of naming, Linnaeus suggested dissociating descriptors of plants from its name. After experimenting with various alternatives, Linnaeus simplified naming immensely by designating one Latin name to indicate the genus and one as a shorthand name for the species. Two names make up the binomial species name. For instance, in his 2-volume work Species Plantarum, Linnaeus renamed the briar rose as Rosa canina. This binomial system rapidly became the standard system for naming species. Zoological and most botanical taxonomic priority begin with Linnaeus. The oldest plant names accepted as valid today are those published in Species Plantarum in 1753, while the oldest animal names are those in the 10th edition of Systema Natura. Although Linnaeus was not the first to use binomials, he was the first to use them consistently, and for this reason, Latin names that naturalists used before Linnaeus are not usually considered valid under the rules of nomenclature. Latin was important language of the time of Linnaeus and continues to be the critical language for international communication. Linnaeus's binomial names introduced an important new idea, namely that the function of name could simply be to give species a unique label. Let's now discuss in detail our third objective, that is, to delineate Linnaeus's thought about fixity of species. Initially, Linnaeus believed that species was not only real but unchangeable, as he wrote, "Unitas in omni specie originem jocet." The invariability of species is the condition for order. But Linnaeus observed how different species of plants might hybridize to create forms which looked like new species. He abandoned the concept that species were fixed and invariable and suggested that some, perhaps most of the species in the genus might have arisen after the creation of world through hybridization. Towards the end of his life, Linnaeus investigated what he thought were cases of crosses between genera and suggested that perhaps new genera might also arise through hybridization. and it's true that hybridization has produced new species of plants and in some cases of animals. Yet, to Linnaeus, the process of generating new species was not open-ended and unlimited. Whatever new species have arisen from prima specia, the original species in the Garden of Eden, were still a part of God's plan for creation, for they had always potentially been present. Linnaeus noticed the struggle for survival he once called nature a butcher's block and a war of all against all. However, he considered struggle and competition necessary to maintain the balance of nature, part of divine order. The concept of open-ended evolution, not necessarily governed by the divine plan and with no predetermined goal, ever occurred to Linnaeus. The idea would have shocked him. Nevertheless, Linnaeus' hierarchical classification and binomial nomenclature, much modified, have remained standard for over 200 years. His writings have been studied by every generation of naturalists, including Aramis Darwin and Charles Darwin. The search for natural system of classification is still going on, except that what systematics try to discover and use as the basis of classification is now evolutionary relationship of taxa. Now let us deliberate about our last objective, scientific works by Linnaeus. Number 1, Systema Natura, the system of nature. In the year 1735, when Linnaeus lived in Netherlands, he published a book named Systema Natura. In this book, he presented a new classification for 3 kingdoms in nature, the animal kingdom, the plant kingdom, and the kingdom of stones, namely regnum animale, regnum vegetabile, and regnum lepidum. The classification was based on 5 levels: kingdom, class, order, genus, and species. While species and genus was seen as God-given or natural, the 3 higher levels were seen by Linnaeus as constructs. The book attracted much attention among the scientists of the time because of its important changes in classification, especially the classification of plant kingdom was new to the world. It followed Linnaeus's new sexual system, where species with the same number of stamens were referred to as same group. Also, the animals were subjected to new classification. For instance, humans were for the first time placed together with monkeys. The first edition of Systema Natura had only 11 pages. Linnaeus later published new editions, each time with new plant and animal species. An important step was when, in 1758, in the 10th edition, he moved the whales from fishes to mammals. The full title of the 10th edition, which was the most important one, was Systema Natura per regna trinatura secundum classes ordinis genera species cum characteribus differentis synonymous loxis, or translated as systems of nature through the 3 kingdoms of nature according to class, order, genera, and species with characters, differences, synonyms, places. The 10th edition of the book, 1758, is considered the starting point of International Code of Zoological Nomenclature. Along with the first edition of Species Plantarum for plants, the 10th edition of Systema Natura are considered as foundation stones of binomial nomenclature. The 13th edition was published in 1770 and comprised 3,000 pages. During the work, Linnaeus changed his classification. Today, there is nothing corresponding to Systema Natura. The number of species has become too large to be assembled in one book. Number 2 is the Species Plantarum, the species of plants. Species Plantarum 1753 is a 2-volume work by Linnaeus in which he established a precise and a workable 2-word or binomial system for naming plants. The system forms the basis of modern plant taxonomy. In this masterwork, Linnaeus described 6,000 species of plants and supplemented each with a generic name, a polynomial descriptive phrase, or a phrase name, commencing with generic name and up to 12 words intended to serve as description of the species, a trivial name of specific epithet on the margin, synonyms with reference to important earlier literature and habitats and countries. Species Plantarum was the first work that consistently applied a referable system of nomenclature. It was vast improvement over the cumbersome polynomial descriptions generally used before its publication. The first edition of Species Plantarum has been internationally accepted as the starting point in the nomenclature of flowering plants and ferns. Let's now discuss about Genera Plantarum. The first edition of Genera Plantarum was issued in Leiden 1737. It contains brief description of 935 plant genera that were known to Linnaeus at that time. Genera Plantarum employed his sexual system of classification in which plants are grouped according to number of stamens and pistils in a flower. Genera Plantarum was revised several times by Linnaeus, the fifth edition being published in August 1754 and linked to the first edition of Species Plantarum. Over the 16 years that passed between the publication of first and the fifth editions, the number of genera listed had increased from 935 to 1105. Linnaeus established the system of binomial nomenclature through the widespread acceptance of his plants in 1735 edition of Species Plantarum, which is now taken as a starting point for all botanical nomenclature. Genera Plantarum was an integral part of his first stepping stone towards universal standardized biological nomenclature. Now the Philosophia Botanica, botanical philosophy. Philosophia Botanica is the first textbook of descriptive systematic botany and botanical Latin. It also contains Linnaeus's first published description of his binomial nomenclature. Philosophia Botanica represents a maturing of Linnaeus's thinking on botany and its theoretical foundations, being an elaboration of ideas first published in his Fundamenta Botanica and Critica Botanica and set out in a similar way as a series of stark and uncompromising principles. The book also established a basic botanical terminology. Let's now discuss about Flora Lapponica. Flora Lapponica, Amsterdam 1737, is an account of plants of Lapland written by Linnaeus following his expedition to Lapland. In Flora Lapponica, Linnaeus's ideas about nomenclature and classification were first used in a practical way, making this first proto-modern flora. The accounts covered 534 species, used the Linnaean classification system, and included, for the described species, geographical distribution and taxonomic notes. It was Augustin Pyramus de Candolle who attributed Linnaeus with Flora Lapponica as a first example in the botanical genre of floral writing. Botanical historian E. L. Greene described Flora Lapponica as the most classical and delightful of Linnaeus's writing. Next is the Bibliotheca Botanica, Bibliography of Botany. Bibliotheca Botanica was written and published in Amsterdam when Linnaeus was 28 and dedicated to the botanist Genus. The preface, dated 8 August 1735, on pages 2 to 19, contain Linnaeus's extended account of botanical history in form of botanical analogy. In pages 2 to 3, Linnaeus lists previous bibliographies and then gives his account of botanical history, leading to a golden age lasting from 1683 to 1703. The preface mentions Bibliotheca Botanica was the first part of Plante's Bibliotheca Medica, which he did not produce. Hortus Californitus. Hortus Californitus is a collaborative work between Carolus Linnaeus and George Genosis Erhet, financed by George Clifford in 1735 to 1736. Some of the other books of Carl Linnaeus are Critica Botanica, Fundamenta Botanica, Nemesis Divina, Systems of Vegetables, Amoenitales Academica. Dear students, let's conclude here. Linnaeus was not big, not small, thin, brown-eyed, light, hasty, walked quickly, did everything promptly, could not stand lateness, was quickly moved, sensitive, worked continuously, could not spare himself. He enjoyed good food, drank good drinks, but was never inebriated by them. He cared a little for appearance, believed that the man should embellish the clothes, not vice versa. He was certainly not argumentative, so he never answered those who wrote against him and said, "If I am wrong, I'll not win, and if I am right, I'll be shown to be right as long as nature exists." The Lenny Herbarium at the Swedish Museum of Natural History preserves some of the Linnaeus's original plant specimens. The museum also has an excellent detailed biography of Linnaeus. You can also view Linnaeus's botanical garden and Linnaeus's manor home and garden at Hembury, courtesy of Uppsala University, Linnaeus's alma mater. Uppsala University also maintains Linnean Lenny, a rich source of information on Linnaeus and his times. Founded a few years later after Linnaeus's death, the Linnean Society of London is still going strong, and as an international society for the study of natural history, the society preserves the bulk of Linnaeus's surviving collections, manuscripts, and library. The Linnaeus's link at the British Natural History Museum aims to make available electronic versions of Linnaeus's writings and documents. Dear students, this brings us to the end of this lecture on the contribution of Linnaeus to biology. Hope you enjoyed this lecture. Have a nice day.